Our new chapter is all about systems of equations, and you will see that in the title. Systems of equations. This whole chapter is going to be me teaching you a bunch of different ways to solve for the solution. Okay? So today, what is the way we're going to be solving? Graphing. So before we get started, let's just talk about what is a system of equations. Does everybody understand an equation is like written either in like slope point form or slope intercept form? Yes, and it can be graphed. Yes? So if I have equations, how many do you think we're going to be dealing with today? More than one, which is going to be 2 today. Okay? So right here, this is an equation. I could write in y equals mx plus b form. Yes? And this is also an equation. Where they meet is called the solution. So everybody right here put a dot and say this is the solution. So there's multiple ways you could be asked this. They could just say what is the solution to the two systems, or they could say what point satisfies both equations. Okay? So right here, this point satisfies this equation and this equation. And there's only one answer because that is the only point where they both meet. So does everybody agree? If there are 2 lines that meet at a point, there's only going to be one answer, but your answer will have an x and a y value. It's a coordinate. Yes? All right, what are these called?
Parallel lines.
These are called parallel lines. Do these ever meet? No. So will these ever have a point that satisfies both answers? No. There is no solution. And how do I write that? A 0 with a line going through it. Okay, and then this last one is like, y'all remember how we were graphing equations and sometimes they would be the exact same equation written in different forms? And so if I graph a line here and then I graph a line right on top of it, then it is touching at every single spot. And so there are infinite solutions, or also how else could we write that? All real numbers. Now, let's just go over some things that we've already learned in previous units. Let's go back to parallel lines. Okay, so if I have parallel lines, who can tell me about their slopes? The slopes are the same. And then if I have 2 lines that are the exact same, then everything's the same. The slopes and the y-intercepts are the same, right? So these have the same slope and same y-intercept. And over here with the parallel lines, the slopes are the same, but the y-intercepts are different if you want to write that. Okay, so today we are going to be given 2 equations and we're going to be asked to solve for the solution, and today we're going to solve them by graphing. Okay, and then tomorrow, or moving on in the lesson, I'm going to teach you different ways to solve without graphing. So they want you to solve this system equations by graphing, and they want you to use slope-intercept form. So y'all remember slope-intercept? You find the intercept, put a dot, and then rise over run. Yes? So everybody look at this first equation. Is it in the correct form for me to graph? No. So what's the first thing I need to do? Rearrange it. I need to move this 2x to the other side, and to move that, how would I do it?
Minus 2x.
Yes, so I'm going to have y equals negative 2x plus 6. And I'm going to go graph this by knowing that the slope is negative 2 over 1 and the y-intercept is 6. And y'all should be really good at this because we did this many, many times in the first semester. So I'm going to go to the y-axis, to the 6. Y'all remember this, yes? I'm either going to rise up to left 1 or down to right 1. So I'm going to go down to right 1. And remember, you can always use your y equals button if you get confused. Does everybody remember how to do that? All right, and then I'm just, it's very, very important that you graph it really good so that you can see where they intersect. So I'm going to go ahead and go down to right 1 all the way through the graph. Okay, now I'm going to graph this equation. What's the first thing I'm going to have to do? I need to rearrange it, so I need a minus 2x. So I have negative y equals negative 2x minus 2. Can I have a negative y? So I have to divide everything by negative 1, which just means change everything's sign. Yes? So this becomes y equals 2x plus 2. So my slope is 2 over 1, and my y-intercept is 2. Okay, so I'm going to go to the y-axis to 2, and then I'm going to rise up to right 1. Do you already see where they're both touching? So I don't have to be as meticulous with this line because I already see the answer. So this point right here is the point that satisfies both equations. It is the solution, the point where they meet. So this is the answer. That's my solution. And then you just write it as a coordinate. So where am I at on the x-axis here? On the x-axis, I am at 1. Where am I at on the y-axis? 4. And that is the answer. Easy? Okay, let's do the next one. The first equation we're going to graph is y equals negative 2. Remember that when it is y equals and there's no x involved, you simply go to the y-axis to negative 2, and it's a straight line that passes through the y-axis at that number. So everybody find the y-axis at negative 2. Put a dot, and it is going to be a straight line that passes through that y-axis on that dot. Okay, so I graphed this one. Now I need to graph this one, but what do I need to do to it? Rearrange. Okay, so how am I going to get this 3x to the other side? Minus 3x. So I have negative y equals negative 3x minus 1. Can I have a negative y? No. So I have to divide everything by negative 1, which just changes their signs to the opposite. So this becomes y equals 3x plus 1. Are y'all good with rearranging? Yes? We've been doing that since the beginning of school. All right, so I have a slope of 3 over 1 and a y-intercept of 1. And just to refresh your memory, if you're not good at slope and y-intercept, once you have it in y equals, you can simply go to your y equals button and type in 3x plus 1, and then go to the table, and it will give you the coordinates to graph. Personally, I think it's easier just doing it this way, but I'm fine with whichever way works for you. Okay, so I'm going to go to the y-axis to the 1. I'm going to rise up 3, right 1. What else could I do?
Go down 3.
2 negatives make a positive, so I could go down 3, left 1. So 1, 2, 3, 1. Do you already see where they're going to intersect? Yes. Now, I do want to see the whole graph, so on your assignment, make sure you're actually finishing. Don't just see the answer and stop, okay? So this is the solution. This is the point that satisfies both equations. So where am I at on the x-axis? -1. Where am I at on the y-axis? -2. That is your answer. Questions? Are we good? All right, let's flip to the back and do some more examples. Okay, look at this first one. How do you graph an equation when there's no y? It's just x equals a number. Where am I going to go? I'm going to go to what axis? I'm going to go to the x-axis to the 2, put a dot. And it's just going to be a straight line that crosses through that x-axis on that spot. So it's a vertical line. Questions? Okay, let's look at the next equation. What's the first thing I need to do with this equation? Rearrange. I need to move this 2x to the right side, and how am I going to do that? Subtracting. So I have y equals -2x plus 1. Okay, so I need a slope and a y-intercept. My y-intercept is 1. My slope is -2 over what? 1. Okay, so I'm going to go to the y-axis to the 1. I'm going to go down 2, right 1. And do you see the answer? Yes, you can see where they're going to intersect. I did not mean to put a curve there. Here is the solution. So now I just write it as a coordinate. Okay, where am I at on the x-axis? 2. Am I going too fast or y'all okay?
No.
Good? Okay. So I'm on the x-axis, I'm at 2. On the y-axis, where am I at? -3. Questions? Are we okay? All right, let's do the next one. Let's look at the first equation. What's the first thing I need to do? Rearrange. Question. What coefficient is in front of this x?
1.
A 1. I'm just going to write that so I can see it. And then I'm just going to put a little line there. All right, how would I get rid of this 1x and move it to the other side? Subtract. Okay, so I have y equals -1x plus 3. Good? My slope is -1 over 1, and my y-intercept is 3. So I'm going to go to the y-axis to 3. I'm going to go down 1, right 1. Now it is super important that you're using your straight edge, because if you freehand it, you're not going to really see where those two lines intersect. Thank you. All right, let's rearrange this one. Are y'all finished with the first one? Okay. So again, there's a coefficient of 1 here. I'm going to move this 1x to the right by subtraction. So I have y equals negative 1x minus 3. I have a slope of negative 1 over 1 and a y-intercept of negative 3. Now stop and tell me, what do you see right here? Their slopes are their y-intercepts are different. That means they are parallel lines. Now I do still have to graph it, but what is my answer going to be? Are they ever going to touch? The answer is going to be what? No solution. All right, but let's go graph it. So I go to negative 3, and then I'm going to go down 1, right 1. Okay, they are parallel lines, so they never meet. So the answer is no solution. Okay, let's go to this one. Okay, what's the first thing I need to do? Rearrange. So let's start with this equation. The first thing I'm going to do is move this 2x to the right by doing what? Subtracting. So I have negative y equals negative 2x minus 3. I cannot have a negative y. So that's really like a negative 1. So I divide everything by negative 1 and it just changes everything's sign. So this becomes y equals 2x plus 3. So I have a slope of 2 over 1 and a y-intercept of 3. So I'm going to go to the y-axis to 3. I'm going to go up 2, right 1. What else could I do? Down 2, left 1. Did everybody get the first one graphed? Okay, let's move to the second one. The first thing I need to do is rearrange. So I'm going to move this 4x to this side by doing what? Minus 4x. So I have negative 2y equals negative 4x minus 6. Okay, how do I get rid of this negative 2? Divide everything by negative 2. Now I just need to simplify. So I have y equals, what's negative 4 divided by negative 2? 2. So 2x. What's negative 6 divided by negative 2? Positive 3. What do y'all see about these two equations? They are the exact same equation. They both have a slope of 2 over 1 and a y-intercept of 3. So if I go graph this, I'm going to be just laying over this same line. Now you don't have to go like graph it again. I'm just showing y'all. It is the exact same line. Therefore, every single point that exists on this line satisfies both equations. This point works, this point works, this point, this, all the way through this line. So what would my answer be? All real numbers satisfy both equations because they're the same equation. Are we good? Yes or no? Okay, let's do this one. what's the first thing I need to do? Rearrange. So let's go rearrange this one. I'm going to keep the y on the left side, right? So am I going to get rid of the x or the 2? What do I have to get rid of first? What's my goal, guys? I want the y by its... Okay, so if I want the y by itself, I got to get rid of x and 2. Which one do I get rid of first? The one that's not attached to it, right? This is its best friend, so the x has got to go first. What coefficient does the x have? A 1. So I'm going to get rid of the 1x first by subtracting. Yes? So I have 2y equals negative 1x plus 3. Now how do I get rid of the 2? Divide, because it's attached by multiplication and the opposite is division. So I'm going to divide everything by 2. I'm going to draw a little line to separate these two. I have a slope of what? Negative 1/2. And I have a y-intercept of, what is 3/2 in decimal form? 1.5. Now, if you want on this one, type it in your calculator. You could literally just go like this and go negative 1/2. Tab out x plus 1.5, and then go to second graph and get your coordinates that you want to graph. So I'm going to graph 1, 1. I'm going to graph 3, 0. 5, negative 1. Now that I have points, I could just rise over run 1 over 2. Down 1, right 2. So it didn't really help me to go to that y-intercept of 1.5. I could have, but my dots just wouldn't be integers. They would be decimals. Make sense? Everybody good with this? So the calculator is helpful on some of these to use that y equals button. Okay, now that I graphed this one, what do I need to do over here? Rearrange. What am I going to get rid of first? Do I need to slow down? Are we good over here? Yes? Okay. All right, to rearrange this, what do I need to get rid of first? The 3x. How do I get rid of it? Minus. So I have negative y equals negative 3x minus 5, because that's a negative 5 right there. This is like having a coefficient of negative 1, so I divide everything by negative 1, which changes the sign. So I have y equals 3x plus 5. Now this one's easy to graph without my calculator. So I have a slope of 3 over 1 and a y-intercept of 5. So I'm going to go to the 5 on the y-axis, and I'm going to go up 3, right 1. Where else can I go? Down 3, left 1. And there's the answer. So this is going to have one answer, one solution, because it only touches in one spot right here. You have to write your solution. You can't just graph it, because then your answer would be wrong. Okay, so you have to write this as a coordinate. So what is the x value of this coordinate? Negative 1. What is the y value of this coordinate? 2. Do y'all want to do 2 more or 1 more? We're going to do at least 1 more. Do y'all want 2 more? Just 1? Okay. Let's do this one, just to make sure y'all are good with these. How do you graph an equation that looks like this? Go to what? You could, but you don't need to. Go to which axis? What does it say? Go to the y-axis, put a dot at negative 2, and then just draw a line straight through the y-axis right there. Mine got a little crooked. There we go. All right, what do I do with this equation? All right, let's talk about it. What is your goal? To get the y by itself. So I need to get rid of 2x and 3. Which one goes first? Because it's not attached to the y. So I'm going to get rid of the 2x by subtraction. So I have 3y equals negative 2x plus 6. I'm going to divide everything by 3. So I have y equals negative 2/3 x plus, what is 6 divided by 3? 2. So I have a slope of negative 2/3, and slopes being a decimal or fraction are perfect. Y-intercepts being that can be tricky. Okay, but we're good because our y-intercept is an integer. So I'm going to go to the y-axis to 2 and put a dot. I'm going to go down 2, right 3. And your solution is the point where the two lines meet. And again, you must write the answer as an ordered pair, a coordinate. So what is the x value of this coordinate? What is the x value of this coordinate? 6. What is the y value of this coordinate? Negative 2. All right, I will pass out the assignment and give directions. Okay, on 1 through 6, it says, tell whether the ordered pair is a solution. So your answer is going to be yes or no. The easiest way to do this is probably by plugging it in. Okay? In order for it to be an answer, it has to be yes for both. So if you do the first one and it's a no, don't keep going. Make sense? All right, let's do number 1 together. What is the x value they're giving you? 0. What is the y value they're giving you? So I'm simply going to take the first equation and see if it's true or not. So I would simply say, is 0 plus, I'm just going to write it over here so you'll have an example, y, which is negative 4, is that equal to negative 4? Yes or no? So that is a yes, so I'm going to put a check mark. But in order for it to be a solution to both, it has to work for both. Yes? All right, so let's try this one. X, which is 0, minus 5 times y, which is negative 4, is that equal to 20? Yes, if you didn't know that, you type it in your calculator. Negative 4 times negative 5 is 20, right? And then you add 0 and you get 20. So 20 equals 20. So yes, it worked for both. So the answer is yes.
If it only works for one.
Then the answer is no. Because you're looking for the ordered pair that satisfies both. So y'all heard the question, yes? What if it works for one and not the other? Then the answer is no. All right, on 7 through 12, it wants you to match. Guys, if it was me, I would just rearrange them and then pick the equations that match it. Just basically like you're graphing them. Does that make sense? So for like number 7, I would rearrange this. I would pull the x to the right and then divide everything by negative 1. And it would be, this would be negative y equals negative x plus 2. And then I would divide, so it would be y equals x minus 2. And then if I rearrange this one, it would be y equals negative x plus 5. And then I'm just basically looking for a graph where this one has a y-intercept of what?
2.
Negative 2. So go to this graph. Does this have a graph where it intersects negative 2?
No.
So skip that one. Does this one intersect at negative 2? Yes. Does it rise 1 over 1? Yeah, so that one's good. Now I'm going to check this one. Does this one intersect at positive 5? And does it rise, over, run, down 1, right 1? So what does number 7 have to be? B. So y'all see how I did that? Okay, that's probably the easiest way. Okay, go down to 13 through 15. These are the easiest ones. They literally give you the answer. It says, use the graph to solve. So they already graphed it for you. Yes? So where's the answer? Right there. Where the two lines meet. Now what is your job? To write it down as a ordered pair, a coordinate. So your job is to put it as an ordered pair and write it down and then box it in for me. I'm not going to do it because it's too easy. Y'all good with that? That's your answer. Here's your answer here. Here's your answer here. Okay? Flip to the back. Now on 16 through 21, this is where you are going to graph it. Okay, even if you see the solution, please don't stop graphing. I am going to grade the graph and the solution. If you just graph, you're going to miss the solution part. So your job, graph this equation, and then right over here or up here, wherever you want, you're going to put the ordered pair where they meet. Make sense? Yes or no? Okay, then I want y'all to do the number 22. Because it's already graphed for you. If you're in Miss Butler's class, go ahead and do number 23 as well. All right, y'all can get busy.
Number